Okay, today we're going to talk about covalent bonds. So, first thing, covalent bonds form between two nonmetals. There are two types of covalent bonds, nonpolar and polar. So, nonpolar are very similar electronegativities. Polar are different electronegativities. So, we'll do a couple of videos here where I'll show you some of the different compounds. But the simplest form of a covalent bond is where something is bonded to itself. Okay, so where the easiest example is hydrogen. Okay, hydrogen gas, H2. So when we look on the periodic table, hydrogen has one valence electron, and so you need two of them. Okay, and so hydrogen, this one and that one bond, okay? So each of these hydrogens are 1s1, okay? But when we connect them and they bond, so this is 1s1, this is 1s1, but when we connect them and they bond, each hydrogen now has access to 2 electrons. So this one is like 1s2, and this one is like 1s2. Okay, now why is that important for hydrogen? That's because 1s2 is a complete energy level, and helium has 1s2, okay? And that's a noble gas, and it's stable. Remember that all the noble gases are stable. Now, most other ones get stable at 8. Hydrogen gets stable at 2 because he's super tiny, only has the one valence electron. So that's basically, that's one covalent bond. They're sharing 2 electrons. Each time you see this line, that symbolizes 2 electrons, okay? Now, when you look at hydrogen, each hydrogen is 2.20. You take the difference, that's a 0 difference in electronegativity. And so this is a perfectly nonpolar covalent bond. Now, when we look at oxygen, oxygen has 3.44. Now, we'll do double bonds next, but if you think about water, H2O, right? So let's do Lewis dot structures for both the hydrogens and the oxygen. So we know from hydrogen, so 3.44 is O, 2.20 is hydrogen. So hydrogen each has one valence electron. Now 1, 2, 3, 4, 5, 6. So the hydrogens we know have one valence electron. And then oxygen is a little bit larger, okay? It's heading out to want to get 8 valence electrons because when we think about oxygen, remember 1s2, 2s2, 2p4. Let's be prepared for an ugly s here. So 1s2, 2s2, 2p4. And so it wants to fill out the 2 level, whereas hydrogen is only filling out the 1 level. And the 1 level can only hold 2 electrons. But this one can hold 8 total, so oxygen actually needs a bond here and a bond here, which is why it's H2O. Okay? So when I draw my water, it's going to be 1, 2, 3, 4, 5, 6. And then I'm going to bond here, hydrogen, bond there, a hydrogen. So counting, the hydrogen now has 2 electrons. It's stable because it has its 2 that it needs. This hydrogen is stable because it has the 2 it needs, and then 2, 4, 6, 8 around the oxygen. Okay? Now, you take the difference between the electronegativities, and that is 1.24, which makes that a pretty polar bond, which means that the oxygen, because it's got a larger nucleus, is actually pulling the electrons that it's sharing closer to itself. And so I'm going to do this little job right here. And that indicates that the hydrogen is going to be have a little bit of the positive pole. The oxygen is going to have a little bit of a negative pole. And because these things have this difference in electronegativity, that's why I put that there, and that's why I didn't put it on the hydrogen, because the hydrogen, it didn't have any big difference. Okay, that's enough for today. I'll put up another one tomorrow with some more covalent bonding.